essentially is a real number part plus or minus an imaginary number part. So complex numbers are going to be like in this form. A plus bi is usually kind of the notation we use. Here, let me try and write that a little bit neater. So you're going to have a real number part and an imaginary number part, and usually you want to make sure you want to get used to putting them in this order. Like you want to put your real part and then your imaginary part. I mean, technically it doesn't matter, but when you're actually doing, if you are doing more with complex numbers, like next year, like in a pre-calc class, or if you take that 1530 class, I think you graph complex numbers in there. So it is kind of important that you have them in this form. I could be wrong though. So, and you can't combine these, they're not like terms, but a complex number is anything in this form, a plus bi. And like I said, this is your real part. So like your real number, like 5, 2, 3, whatever it is. And then this is your imaginary part. So like 2i, 3i, whatever it might be. So we're going to look at operations with complex numbers. Just to kind of see how we can add or subtract these together. Adding and subtracting is pretty straightforward. It's pretty much just like combining like terms. So maybe I'll do the odds, and then maybe oh wait, there's 3 addition and 1 subtraction. Okay. Maybe I'll do the odds and have you try the evens. But so if you're adding, you basically want to add your real parts together. So -11 plus 9 would be -2. And then you're going to add your imaginary parts, or your I part, together. So 3i plus 2i would be 5i. So that would be our answer. And like I said, you want to make sure it's in this form a plus bi. I mean, I probably would never mark you wrong if you wrote 5i minus 2, because it's technically equivalent. But you do want it, like, especially if you're doing more with these, your teacher's going to want you to put them in this a plus bi format. Let's look at number 3, a subtraction. Just be careful, especially with subtraction questions. You either want to distribute and rewrite it, because like it basically you're subtracting both parts, or you kind of want to just go through it one at a time. So like if you do your real part, 7 minus 2 would be 5. Like if you wanted to look at the original, 7 minus 2 would be 5. And then -2 minus 6i would be -8i. So you either want to rewrite it, like distribute that minus sign, or like I said, just look at it one piece at a time, but just be careful, like make sure you subtract like each piece. So that like plus 6i, you're really going to subtract 6i. So be careful when you see a minus sign. So how about you guys give, if you want to take a second, try number 2, try number 4. 4, you've got like basically 3 separate kind of complex numbers that you're going to add or subtract together. So if you can do number 4, you could pretty much do anything with adding and subtracting. So I'll give you a second to try those. Hopefully too bad. But like I said, for number 2, you would add your real parts. So 4 plus 7 is 11. And then you do your imaginary part. So that would be like 1i plus -5, because it's subtracting. So that would really be minus 4i. And a few people just sent me that. So yeah, good. A couple of people sent me number 2. Both of you guys look good. So, but please let me know if this isn't making sense, because I mean, I can take a step back. So the next question, I mean, like I said, with the subtraction, you can either rewrite it, or you can kind of just go through it one part at a time. I'm not sure what's easier. Like if you want for number 4, you could rewrite it like this, like distribute the minus sign. And the plus, I mean, it just doesn't change. So you basically get rid of it. So you could do it like that and then combine, or if you want to just go through the original, just be careful with your signs. So we want to do the real part first, because we want to get it in a plus bi. So we would really have -14, because that minus, plus 5, so that would be -9. And then do your imaginary part. So you have positive 6i minus -i. So that would really be like plus 1i. So that would be 7i. And then plus -3, that would be 4i. So I don't know if that makes sense, or if it's easier, like I said, if you want to, it might be helpful to rewrite it, like distribute your minus signs. So that would be minus 14. That would be plus I. And then when it's plus, you just kind of get rid of the parentheses. So then if you can combine it, you can see you still get the same thing. So if it's helpful to rewrite it, go for it. But if you don't need to rewrite it, like personally, I wouldn't care if this was like a quiz question, um, like if you went straight to your answer or not. Because I mean, in theory, you could do it without writing if you do it piece by piece, kind of like in your head or in your calculator. I don't know if you guys have, how many of you guys have a graphing calculator? I was looking, there's like an app that's really similar to a graphing calculator. I might start using that after winter break. I kind of want to like sit down and mess with it. But just so you know, when you do get a graphing calculator, or if you have one, there is a way to put in like an I into your calculator. So even if if you are having trouble with those powers, like if it's months from now, like you can do like I up to certain powers in those calculators. So you know, I mean, I would still like you to kind of be able to do it without a calculator, but like when you do get a graphing calculator, you can kind of plug those in there if you have one. Being rich, but yeah, that's one thing. Like especially, I honestly didn't think we would be online this long, so I was just like, oh, we'll be in person. We'll deal with the graphing calculators then. But it's definitely a good chance we probably won't even be back in person after winter break with how things are looking. So I did find like there's a free app for like iPhone or Android that's it's pretty much the same as a graphing calculator, like the TI-83, like the layout's like nearly identical. They basically copied the TI-84 as much as they could so they wouldn't get like sued, I think, or taken down. But it's really similar. Okay, so the next operation we're going to look at is multiplication. The really important thing to remember when you're multiplying is that I squared equals -1. We're going to use this a lot of times to help us simplify these some more. But when you're multiplying either imaginary numbers and complex numbers, you're either going to distribute or you're going to FOIL. So we'll do a little bit of practice of FOILing if you haven't FOILed in a while. But for 5, you would just distribute 2i. So that would be 16i minus 6i squared. But remember, this I squared is -1. So usually how I write, like it flips your sign. So this would be 16i, and that's really this.
This is the part that keep messing me up. I don't know nothing about these eyes.
So this would turn into a +6, if that makes sense. Basically, if you see an I squared, or you can pull an I squared out, it disappears and it switches your sign.
So if I got -6i to the second power, it just basically means
Switch your
-6.
sign essentially, because I squared really is -1. So really what that is, that's really -6 times -1. If you like,
That don't make sense to me.
because it's just based on what I squared is. So here, maybe I'll write it out for this first one, but usually I don't write it out because I just like eventually you want to avoid writing it out just because if you're lazy like me. But this is really this, like you substitute in what it equals. So that would just be 16i plus 6. And then technically, like I said, you should put in that form a plus bi. So you would want to kind of swap these around. Like I said, I'm usually not too picky because usually what we're doing in this class, we're usually not doing too much once we get our complex answer. But if you're in a future class, like if you're graphing or if you're doing more, sometimes it can be pretty important to put it in this order. But so if you want to get into a good habit, try and do it. But like I said, if you put 16i plus 6 like on a Google form or a quiz or something like that, I would take it. I'm not sure how picky. We'll have to see how picky Delta Math is. They might mark you wrong, but you want to make sure it's in that order. Always your real number, then your imaginary part. All right, let's look at another one. So going to multiply this -I. So just basically treat it like a variable. So, oops, that would be positive 2 because negative times a negative. So it'd be 2i minus 10i squared. And like I said, I mean, you don't have to write this step, but remember, I squared is -1. So basically it goes away and it switches your sign. That -10 turns into a +10. And like I said, you do want to put it in that order, like the real number and then the imaginary number. Like I said, it's usually not like something that grinds me, but I'm usually pretty chill when it comes to notation and stuff like that. Some teachers you'll have will be will be much more picky or particular about how they want you to write your answers. And sometimes it's for a good reason, like if you're doing more. But like I said, in terms of this class, usually once we get an answer like this, we're done. We don't usually do too much. We're really not going to do anything with these complex numbers. If you just have like a negative I, like you would just keep an I. If I'm understanding right, Brooklyn. Like when we're doing like these types of questions, I mean, negative I in general would just be the negative square root of -1, though, if you like were. Oh, geez. Positivity in the chat. Okay. Let's look at a question like 7. I don't know how good like how familiar you guys are with foiling, because honestly, we really haven't done a lot of it, if any, in this class. I mean, surprisingly. So when you FOIL, remember you take your first number and basically distribute. So that would be 28 minus 7i. And then you take your second number, like in the first binomial, and then kind of distribute that number. So that would be plus 4i. And then that would be minus I squared. In the chat, I see some people got it. So then you just want to combine your like terms. So it's always your real number first. So if possible, like I said, if you can avoid writing this, you don't have to write this step, but you want to simplify the I squared. Remember, that's just going to be, oops, I'm not writing. That would be minus -1, or you could really rewrite that as a +1. So then you want to combine your like terms. So your real part would be 29. Your imaginary part would be minus 3i. And like I said, if you like, you don't have to write this step out. Like you want to get to a point like where when I see a minus a squared, like, well, and like the I squared is going to go away and it's going to switch my sign. So that's a +1. And then I would combine it kind of all at once in my head. So maybe I'll kind of show you that in question 8. So if you FOIL, like you take your first number, distribute, that would be -10 minus 6i. Take your second number in the first binomial and distribute. Since it's a minus, treat it like a -4. So that would be plus 20i. And that would be plus 12i squared. So your real part, because remember, this I squared is going to really turn into a real number. So the opposite of 12 would be -12. So -12 and -10 would be -22. Then your i's 20 minus 6 or 20 plus -6 would be 14i. Let's see. If you ever see a question squared, remember 6 minus 2i squared. You can't just like square both parts. You need to really rewrite these two. Like this problem is really 6 minus 2i times 6 minus 2i. So how about you give number 9 a try? But if you ever see something squared, basically write the same binomial twice and then FOIL it out. You do need to take the time to FOIL. I mean, there are some shortcuts you can learn. Like there's some like, you'll kind of notice some things. Like there are some like for squaring like the same binomial, like either with a minus or a plus. There's things you can memorize to kind of save some time, but you really want to rewrite it unless you learn those. But here, so I'm going to pause, but try number 9. And if you're feeling when we look at different types, whether it's complex or not. Hit me. Sorry, this is gonna be awkward if someone's watching. There's gonna be an